Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Today we are going to discuss a topic related to the course of structure analysis. We are going to actually to talk about a real project. Our project will be a real project uh, called Vardan Garden. This project you can search it. You can search for it inside Google, and you will by Google you can see this. This is the final landscape located in our real world. Okay, so our project consists of 4 blocks. So we have a block B, which is a residential, block C an hotel, and the block A and A prime are both shopping centers. So our presentation today will discuss actually what we are going to take in the next lessons from analysis to design. Okay, so we have an introduction 1 now. It will talk about the project analysis and the project plans, the project showing system, and we will see now. So first of all, we are going to talk about the design criteria. So our project was built in 2007. So we are going to use ACI 2002, but we will change it to the latest one. Okay, and UBC 97. This code ACI is used to design all the concrete element. Actually, this one for earthquake, we will do dynamic and static, and we will use also the time history analysis. Okay, for dynamic analysis. Okay. The American this code is used for steel construction also, and no, sorry, not for steel construction. The AISC for steel construction. This is for wind pressure. We will see now. These are the materials will be used in our project. So of a prime C for plane, for horizontal, for vertical elements, and the steel yielding strength for mild steel and high tensile steel element. Okay, so the loads, we have gravity loads, we have live loads, and we have lateral loads. Sorry, gravity loads, we have any gravity loads, dead loads, live load, and we have in lateral loads we have earthquake and wind load, wind pressure. Okay, also we'll talk about the shoring system, which is our A phase. Okay, first phase after seeing the plans. Okay, we will use plaxis, the latest software also, and we will do a manual analysis. We have 2 sections for design. We have 2 sections for the building showing system. We have a section we will show you now. We have adjacent building here, and we have adjacent road here. So this is our first section. We have several soil layers. Now these steps of execution, when we are doing the foundation or the shoring system of our project, we have steps of execution. First of all, we have a diaphragm wall. We have to excavate first layer, do anchorage system for both sides as required by our structural analysis for shoring. We have excavation also, and we have also installation of the second anchor, excavation, and so on. We have this phase here is for installation of the bracing beam. Okay, So not only one beam, we have a spacing 5 meters, so each beam is spaced 5 meters next to each other. Okay, we have excavated also layer, bracing also second bracing beam, and we have final layer. We have to also to check the total displacement. The total displacement can be calculated using our plaxis software, and we can check our result. This is the left wall and the right wall. We don't have right wall. This result from manual calculation. Okay, so this is the shoring system, the bracing beam here. Okay, now section with adjacent road. We have a block B and the block C. Now these model were used in Etabs, the older than the latest one here. So we are going to use the latest version of Etabs in order to model these two models, block A, and we have a block C also. We have this. These are the plane for this plan for block B, sorry, and block C. Okay, slabs. These result from to achieve diaphragm behavior related to wind. These results are related to wind. We need to check the wind analysis and the dynamic analysis. Also, we will do scaling for the base shear, and we will add to this method time history analysis. Okay, and we will check the elastic, sway and drift, and we will do sizing of structure element. Actually, we will do an elastic and inelastic. Okay, the elastic will be used in what? In sway and drift. The elastic where after we check the sway and drift. Okay, so but here we have to pay attention that this value here must be when we are going to use the PT slab, we have to multiply them by 1.5. Okay, so these are for stiffness modifier. So here this note here, the values for slab should be multiplied by 1.5 for PT slabs. Okay, so here we are going to check the sway controlled by wind pressure, and we need to check the drift controlled by earthquake load, dynamic and static. Okay, we will add, as I said, the time history. These are the sizing of structure element for wall and column, tributary area versus numerical. We will check also. These are the limitation when we are going to use the sizing of our structure element. These are for column, and these are for wall. We must not exceed them. Okay, these are the structural drawings for block C. Okay, structure system used. We have a wall, we have a column, circle columns. These are the structural drawing for block B. The slab is controlled by the fraction requirement. The slabs for our project will be post-tension slab using Adapt or Run concept. We can use both software in order to model the post-tension slab, and we are going to use also two-way slab, solid slab using SAFE. So we are going to use the allowable deflection related to this one, floor attached to non-structure element. Okay, the post-tension slab. This drawing here is from Adapt Builder. The results are also from Adapt Builders. Actually, this one too, deflection diagram, two-way solid slab from SAFE. We will check the deflection also, and we will do for block A, sorry, which is a steel structure, at, as we can see, it's not a high-rise structure also. So this is the corrugated slab. Corrugated sheet slab was used also. We used in 2007 actually a software called Comdic, but what we are going to use, this slab can be modeled as waffle slab. We can see this software. Let's see, this is our corrugated slab, sheet slab also. So we can use a waffle slab actually. Okay, so these are the calculation result, manual calculation result for secondary beam, for main girder. Related to steel structure, column used is pipe with outer diameter, and so on, road carrying. Here we can check using the plane. This is the plan of secondary and girder section. We can use either SAP or CSI column to check the refraction for beams and so on. Pipe details. Now for foundation, we used a raft foundation actually, but thickness of 2.5 meter. All punching shear are correct for block B and for block C, but we can notice after doing the analysis for our raft for block B and C, that what the soil pressure is greater than the allowable bearing capacity of the soil. So the allowable bearing capacity of the soil was taken from the geotechnical report. Actually, when we were testing the soil, we got this result: 4 kilogram per centimeter square. So this lead us to what? To combine the raft with pile. So pile foundation may be used as a solution. Okay, so we also this is soil pressure for block B and C, and this one we used pile. So we used pile with 60 centimeter diameter for both block B and C. Spacing is 2 meter. Okay. Okay, so here we used allpile software. Allpile software to model the piles. We took, of course, the result from SAFE, and also we checked manual calculation we did. Okay, and so on. For block A, we are not going to use actually raft because it's a steel structure and we don't have so much floor in block A, so isolated footing will be enough for us. Okay, so we used Etabs to take the loads, and we use robot actually to size the isolating footing. Okay, and this is all for the analysis now. Thank you for your attention. The second introduction will be about the design before starting starting the use of softwares to analysis and design our structure. Thank you.